Dear students, whenever two bodies move along a straight line or even in different direction, then we can always measure velocity of one body with respect to another, and such velocity is called the relative velocity. So, how to measure relative velocity when the two bodies are moving along the same direction? How to measure the relative velocity when they move in different direction? So, that is what I am going to explain. So, first, what is the relative velocity? Velocity of one body or one moving body with respect to another moving body is called relative velocity. So, let us take an example here. So, there is a body moves in one direction, and I am going to name it as A, and let V suffix A be the velocity of that particular body. And in the same direction, there is one more body which is a B that moves with another velocity which is B. And now when two bodies are moving simultaneously, we can always measure velocity of A with respect to B, or you can even measure velocity of B with respect to A. So, what is the meaning of VAB? And we read it as the velocity of A with respect to B. That means velocity of A as observed by B. How velocity of first body it appears to the second. That is the meaning of velocity of A with respect to B. Similarly, velocity of B as observed by A. How to calculate this? Relative velocity of A with respect to B is always equal to the difference in the velocities of the two bodies. That is, in this case, it is a VA minus VB. VAB is equal to VA minus VB. Whereas VBA is equal to VB minus VA. The velocity which comes first here has to be written here. So, this is the velocity of A as observed by B. This is the velocity of B as observed by A, which is always is equal to difference in the velocities. What if the two bodies are moving in opposite direction? That is, here they move in the same direction. So, this is V suffix A, this is a V suffix B. So, how to find VAB in this case? So, VAB is equal to, it is a VA minus, this vector is opposite to this particular vector, right? And any two vectors which are opposite to each other, in that case one is taken as a positive and the other is taken as negative. Therefore, VAB is equal to VA minus of minus VB. So, that becomes VA plus VB. So, this is the relative velocity of A with respect to B. So, here you can see it becomes VA minus VB, here it becomes VA plus VB. Why it becomes VA plus VB? Because the two bodies are moving in opposite direction. Here they move in the same direction. How to write VBA in this case? So, VBA is nothing but, it is already minus sign. So, that is why it is a minus VB, because I have tried B first and then A, minus of VA, which is a minus of VB plus VA. So, this is the relative velocity of A with respect to B, this is the relative velocity of B with respect to A. So, relative velocity is a minimum when the two bodies move in the same direction. Relative velocity is maximum when they move in opposite direction. Now, why I am using the word minimum and maximum? Because here it is the difference. The difference will be always less. Whenever you subtract, the value reduces. Whenever you add, the value increases. So, that is why relative velocity is a minimum when the two bodies move in the same direction. It is a maximum when they move in opposite direction. So let's go through some of the question. When is the relative velocity of two moving objects is 0? So you take this example here, let us take VA is equal to 60 kilometer per hour and VB is also 60 kilometer per hour. So now let's find the relative velocity. What is that equal to? 60 minus 60, that's equal to 0. So relative velocity of two moving objects is 0 when both the bodies move in the same direction with the same velocity. The two bodies, they must move in the same direction with same velocity. What happens here if one is a 60 kilometer per hour and the other also moves in this direction with the speed of 60 kilometer per hour in the opposite direction? In our case, the two values will get added up, 60 plus 60, it becomes 120 kilometer per hour. So this is the reason why whenever we are traveling, on highway, when our vehicle moves in one direction and if there is one more vehicle moves in the opposite direction, and if we are moving with the speed of 60 kilometer per hour and if that also moves with the speed of 60 kilometer per hour, it appears for us that the other vehicle is moving with a very high speed of 120 kilometer per hour, because we are also moving, the other vehicle is also moving in the opposite direction. So therefore it appears that the two vehicles are moving at a great speed. So that is velocity of one object with respect to another object, and that is what we call the relative velocity. So what is the next question? When is the relative velocity of two moving objects minimum? And the second option, maximum. I have already explained that it's a minimum when the two bodies move in the same direction, and it's a maximum when the two bodies they move in the opposite direction. So next we have something called position time graph. Draw position time graph of two objects moving along a straight line when their relative velocity is 0, that's option 1, and the second option when it is non-zero. So now to draw this particular graph, I am going to first explain what is a position time graph, and then I will come back to that particular question. Okay. So what is position time graph, xt graph? Explain. So we have already learnt about the Vt graph. Velocity is taken along the y-axis, time is taken along the x-axis. And now a graph obtained by taking position, which is represented by x, along the y-axis, and time along the x-axis is called as position time graph, or it is also called as xt graph. So what is xt graph? A graph obtained by taking or plotting positions along the x-axis and the time along the positions along the y-axis and the time along the x-axis is called as position time graph. Now what we can understand out of the position time graph? Let's take different types of the graph. In the first graph, as the time increases, the position you can see remains the same. That means in the graph 1, the body is always at rest. There is no change in the position with respect to time. So if the body is at rest, then the graph will be a straight line parallel to the time axis. The second one, as the time increases, the position also continuously increases, and it increases in such a way that the body moves with uniform positive, or we can write positive uniform velocity. The second graph is for positive uniform velocity. So if a body moves with uniform velocity, then the xt graph is a straight line that passes through the origin with the positive slope. The third one, again it's a straight line, but you can see the position is continuously decreasing. So that's why the body moves with uniform negative velocity or negative uniform velocity. So the first graph, if the body is at rest, it's a straight line parallel to the time axis, And again, if it is a straight line with constant slope, then the body moves with uniform velocity. Continuously there is a change in the position. And here you can see the slope, this angle is very large, so more than 90 degrees. So that indicates that the slope is negative and the body moves with the negative uniform velocity. Negative uniform velocity. So suppose if I take the graph something like this, according to the graph number 2. So here I can measure something called the slope, this angle, okay. So the slope is always the ratio of change in the y-axis, that is this, to the corresponding change in the x-axis, that is the dx by dt. And I have already given this formula earlier. What is dx by dt? Dx by dt is nothing but instantaneous velocity. Instantaneous velocity. So slope of xt graph gives instantaneous velocity, whereas the slope of vt graph gives acceleration. The slope of xt graph gives instantaneous velocity. So that's why here the velocity is or the slope is constant, and that's why the body moves with uniform velocity. And in the next, again slope is constant, but the slope is negative. That's why the body moves with uniform negative velocity. In graph number 4, it's not a straight line. It is a structure which we call parabola. In this, the slope continuously, you can see, continuously changes. This angle continuously changes. And you can see it is maximum and then it decreases. So slope decreases. Slope is nothing but velocity. Velocity also decreases. What is the meaning of decrease in velocity? Decrease in velocity means the body has a retardation. So that's why in graph number 4, the body moves with uniform retardation. It is uniform retardation. And in the next graph, which is graph 5, graph number 5. This is the graph, and here the slope continuously increases. You can see the angle continuously increases. So slope increases, velocity increases, which means body has a uniform acceleration. Uniform acceleration. So these are the 5xt graph. What is xt graph, by the way? Graph obtained by plotting positions along the y-axis. Symbol for that position is x, and the time along the x-axis is called as position time graph. And slope of xt graphs gives instantaneous velocity. The graph number 1 indicates that the body is at rest. The graph number 2 indicates that the body moves with uniform velocity. The graph 3 indicates that the body moves with uniform negative velocity. Graph 4 indicates that the body moves with uniform retardation. And the graph 5, fifth graph, indicates the body has uniform acceleration. So the advantage of the xt graph is that we can learn the nature of motion of the body, and these are the different nature of motion for which we get different graphs. And this is an important topic. So repeatedly they have asked questions in the exam for 1 mark or 2 mark to draw certain types of the graph. Draw xt graph when the body is at rest.